I'm the dean of the school here. Okay, that's good. I hope I'm recognized. So this is going to be a little bit different today. I do think with our seminars, I like to have it mixed up. So not all strictly, scientific presentations or professional presentations or careers. And this is a little bit different still, I'd say. For those of you who know something about me, I'm an engineer, but some of you know I'm also a physician. But you may not know I also have a doctorate in environmental sciences. So I cover a lot of bases. And this talk has sort of evolved over the years as my career has evolved. But it involves everything from engineering to public health to the environment to economics to ethics, as you'll see. And I'm going to try to weave it all together, hope it all makes sense. And I like to start off with the 3 Qs. The 3 Qs are a quip, a quote, and a quiz. So this is the quip, a joke, right? This is supposed to be a joke. Now, so listen very carefully, because I was saying some audiences don't seem to get the joke. But so how many of you have heard the joke about the Dalai Lama at Pizza Hut? Anybody? No. Okay. So here's how it goes. Everybody know who the Dalai Lama is? Maybe that's the problem. Anybody who doesn't know who the Dalai Lama is, right? The head of Tibetan Buddhism, right? And was the political leader of the country until the Chinese took over. But okay. So the Dalai Lama is visiting the United States. Picture this: walking down the street, looking at the storefronts. He's looking at the storefronts. He comes to the Pizza Hut, okay, and he sees a sign in the window. And the sign reads this. It says, "Let us make you one with," and that has a long list of things. Let us make you one with extra cheese. Let's make you one with sausage, pepperoni, blah, blah, blah. He reads down the list. He gets to the bottom and goes, he rushes inside to the counter and says, "Can you make me one with everything?" Buddhist monk. Ah, okay, you got it. Okay, you got it. Okay, so the guy at the counter says, "Well, of course I can." He goes, makes the pizza, brings it up, puts it there. The Dalai Lama gives the $20 bill, takes the box, goes to leave, and the guy behind the counter says, "Wait, what about your change?" And the Dalai Lama says, "No, change must come from within." All right, we got a good audience. Now, it's a joke, but I want you to think about this. If you want to be one with everything, we're talking about the environment here, okay, or all your fellow people in the world, and you're all health professionals, biomedical engineers, so you really want to help the world, help all those people, right? If you want to be one with everything, change has to come from within. We're going to get there. Okay. And those of you who know me, I love Einstein quotes, right? So he was a pretty smart guy. Could never find a good barber, apparently, but smart otherwise. And so this is one of my favorite quotes. "The world we have made as a result of the level of thinking we've done thus far creates problems that we cannot solve at the same level of thinking at which we created them," right? So if you want to be one with everything, you want change, you have to change totally how you think about things. I'm going to show you how my thought process has changed over the years. And finally, this is a pretest, okay? This is the quiz. How many of you know the trolley problem? Have you heard of the trolley problem? Okay, one person. Okay, but most of you not. I'm not going to go through the original trolley problem, but this is my changed version of it for this talk. Okay. So in this trolley problem, you're the person standing at the switch, right? And the reason it's called a trolley problem, it was originally written by a British philosopher. Her name was Philippa Foot. Oxford trained, ended up at UCLA, actually, as an endowed professor. But it's become a very famous problem. There's a whole school of philosophers called trolleyologists now. Okay, so we can talk about that later. But here's my version. The original version is interesting, but this is a little bit different. So you're standing at the switch, and you see this runaway trolley coming down the track. Okay, and tied on the track, some villain has tied this poor innocent person to the tracks over here. If you do nothing, trolley will run over that person and kill them. If you throw the switch, you'll save the person, but your expensive sports car, which you accidentally had parked on the track while you were walking along for whatever reason, is going to, this is the dream of your life. You saved all your life. This is your second childhood, right? You bought your most expensive sports car. You took it out and you parked it on the trolley track for whatever reason. It got stalled there, let's say. So anyway, if you throw the switch, you're going to have to sacrifice your expensive sports car, which you just got, okay? But you'll save a life. Now, so the pretest is how many people would throw the switch and save the life and sacrifice your car? How many people would not throw the switch? Okay, remember that. To save one life, you would sacrifice something expensive and personal to you. Okay, now, how did I arrive at these three things? Well, let's talk about environment. So I said environmental science. So environment, this should be no surprise to you. Some of these figures some of the slides are a little bit old, but it hasn't really changed. The environment in which you live is very important to your health. Should be no surprise, right? Depending on the country you come from, the type of climate, et cetera, the pollution. And it's a significant, contributes significantly, right? In fact, what I tell the medical students is, if you could ask your patient, what's the one number you'd like to know from that would tell you the most about their health? What would that one number be? Zip code in this country. Zip code determines your health more than anything else they could tell you. So where you live is very important. Okay, and that's, like I said, that should be no surprise. Okay, and the other thing that's always fascinated me is, and there's a long story behind this, but obviously, if you're not healthy, you're not going to be a productive member of society. And this notion goes back at least to Adam Smith in The Wealth of Nations. He realized this because when he was writing in England, started the Industrial Revolution, the environmental situation of most workers was really pretty poor. And he was concerned about that. I like to think he was concerned just because he liked people, but he was also concerned because he thought it would affect the economy of Great Britain, right? That if the workers were not healthy, they would not be as productive as they could be. And this, the most recent reference to this comes from, I used to be at Columbia where Jeffrey Sachs is a developmental economist, and he's written a lot of books about this. But his point is that if you're poor, you're going to be living in a bad environment, and therefore you're not going to be healthy, so you're not going to be productive, so you're going to be poor. It becomes a vicious cycle of poverty leading to poor health, leading to poverty, leading to poor health. Okay, so environment affects health, affects the prospects of your possibility of making money in the world and having a productive society and world. Okay, so why do I bring all this up? Because I spent a number of years working in Bangladesh. And I break this part into two parts. One, acting locally. When I say locally, I mean acting in Bangladesh on the ground, not locally here in Philadelphia, but it could be here in Philadelphia, as opposed to thinking globally, which is the next part of this, okay? So there's a very long story behind this that I don't have time today for this whole story. Maybe I'll come back another time and talk to you about everything we did in Bangladesh, but we were really there because of water pollution. And that's the first one, although we looked at all the other things, and we'll get to climate change in a minute. But in terms of water pollution, Bangladesh, I assume you all know where it is, right, on the map here, right? This is Bangladesh, that's India, China, Bangladesh. And you can see there are two major rivers, the Brahmaputra and the Ganges, join there and go into the Bay of Bengal, right? So it's a country with a lot of water, a lot of surface water, right? In fact, in the monsoons, it floods all the time. How many people from Bangladesh here? Do we have anybody from Bangladesh? Okay, so the problem is that people were relying on the surface water for everything, including their drinking water and their bathroom and their animals' bathroom. So you can imagine Bangladesh has a lot of problem with diarrheal disease, a serious problem, not just, you get diarrhea once in a while. The kids in Bangladesh, their pre-age 5 mortality is largely determined by the bouts of diarrhea they get over the years, because it leads to malnutrition and they die from infections after that. And then, of course, periodically they have epidemics of cholera. So the surface water in Bangladesh was a problem. And what happened was the world tried to solve the problem for Bangladesh. So what they figured was that if they weaned the people off the surface water and had them drinking the groundwater, meaning you drill a well and you hit aquifers underneath the ground, right? That water would be clean from microbes, right? That's true. Right? Soil acts as a filter, takes the microbes out. You get rid of the diarrheal disease, which in fact it did, because what they did is they drilled millions of wells around the country into the ground, very primitive wells. Didn't have to go very far. The first water table is about 30 feet down in Bangladesh. So you can just actually take a PVC pipe and hammer it into the ground and you have a well. And that actually did solve 75% roughly of the cases of diarrhea in Bangladesh. Now, but here's and you can see that but right now 3 or 4 million wells have been installed. But what the people didn't think, and this is an engineering lesson I like to emphasize. They tested the wells for microbial contamination because that's what they were trying to solve. But they didn't test for anything else, okay? So one of the engineering lessons you should take is when you solve a problem, make sure you didn't make another problem worse, okay? Think about what could go wrong, not just what you made right, but what could go wrong with what you did, okay? And what went wrong is they didn't test for anything else. And Bangladesh happens to be one of those places in the world, in a very spotty distribution, but throughout the country, where there's arsenic in the groundwater, okay? For very interesting reasons, the chemistry, the hydrology, is all very interesting stuff. I can't go into that. But what that meant was, since the 1970s on, the population was poisoning themselves slowly with arsenic. This is not the amount of arsenic that would make you drop dead if you drink it, but slowly over the years, you're going to get all the diseases that arsenic can cause, which is many, including cancer, okay? So for a couple generations now, the population has been slowly poisoning themselves. They're not getting diarrheal disease as much, but they are being poisoned. And you can see 97% of the population now drink. If this campaign was successful, don't drink the surface water, drink the groundwater, drink the well water. And this is probably affecting at least 40 million people in terms of the poisoning. And it's not the whole population of Bangladesh, about 150 million. And the reason it's not everybody is because the wells, even wells a few feet apart, as I'll show you, one can be loaded with arsenic and one can be perfectly clean for very interesting chemistry and hydrology reasons. So we were there. Why did we go to Bangladesh? Because in this country, at the time we started, the government was interested in setting a drinking water standard for the United States for us as for an acceptably safe level of arsenic. Okay, so I was working with a group of toxicologists and physicians who were interested in this problem. And normally, anybody have an idea of what we'd normally do in this country if we said, here's a toxic exposure, how do we figure out what's safe for people? Anybody have a guess at what we would normally do? Take some laboratory animals, and you give them a high dose, and you wait a little bit of time, and you see what the diseases they get. And then you take that endpoint, and you try to extrapolate to a lower dose in a human population, okay? That's what we would do with 99% of anything else. Before we do any other studies, we do that, okay? Now, the problem with arsenic is it causes cancer, but it doesn't cause cancer in laboratory. In fact, it only causes cancer in primates. You can't study rats and mice. You could study, millions of monkeys, but that's difficult too. So the real answer you want to know is not what it causes disease in inbred laboratory strains of rats, right? You want to know what it causes in outbred human strains of population, right? So the best thing to do is to study human populations. And unfortunately, around the world, there are many human populations that happen to be exposed. So and Bangladesh is one of those places. A lot of people in one place, a lot of them drinking some poisoned water, and a lot of them drinking a little poison, and a lot of them drinking no poisoned water. So you can do a dose response curve and say, okay, if you get cancer at this level, we can accept maybe 1 in a million extra cancers from the population, but not 2. So you got to know where that break point is. So that's why we were in Bangladesh, to study the population and to find a place where there's this dose response, right? Where some people are drinking clean water and some people are drinking less clean water and some people are drinking dirty water. And Bangladesh and arsenic can cause all these, I won't go into all these health problems, but I'll point out a few that I think are highly relevant. One is it can cause cancer, okay? But that takes years usually to develop. The first thing it does is affect the skin. This is how it was identified originally by some very astute clinician who's seeing patients with all these strange skin lesions. And they're strange because they're like warts, okay? And they're like warts, but they usually occur on the palms of the hands and the soles of the feet. Very unusual, right? That only happens basically with arsenic. So this person said, oh yeah, it's probably arsenic. Where's it coming from? From the water. And the problem is it can start like this with these little bumps on your hand or this changes in coloration, but it can progress to more serious disease like skin cancer where you have to be amputated. Now, in Bangladesh, it's not uncommon to let diseases like this progress to that serious stage. In this country, you cut those things off, you wouldn't have to worry, right? Mostly. But in Bangladesh, just think about it. If you can't work with your hands and stand on your feet, this is a manual labor economy. Think about that productivity of the population goes down. You can't work, even if this is all you suffer. But of course, you can suffer many other things. It causes endarteritis obliterans, meaning your arteries close down in your hands and feet, in your heart. 6-year-olds get heart attacks because of this, and strokes. Okay, so you can see that's auto amputation of the digits from exposure. So you get cancer in many organs, including the lung and the liver. And in this country, when we set a standard, we tend to set it on the basis of cancer. That's the most frightening endpoint for most people. So we were interested in how much cancer would you get by drinking this water in this population, okay? We were also interested in one other thing. Arsenic, we knew it in adults as opposed to arsenic, it makes them a little mentally deficient. What about developing kids? Suppose you were in utero exposed to arsenic from your in utero on as a child. Would it affect your mental development, right? Once again, affect your mental development, like lead used to do in this country, that's going to affect your productivity for life. Right? So it's a bad thing. Arsenic is very bad. We all know that. We were trying to determine what would be a safe zone. The reason we didn't do it this country is most people move around too much. It's very hard to follow tens of thousands of people. In Bangladesh, you find a population, they don't move. In fact, they're still being studied. This is now 27 years into the study, and this population is still being studied. I'm just an advisor now. So there's a map of Bangladesh. We had an inkling from the British Geological Survey. The color map shows you sort of the well water levels for large areas in Bangladesh. We chose a little bit of area outside the capital, which is in the middle of the country. Each dot here, was our study area. Each dot represents a well. We picked an area where the colors ranged, as I said, from red, bad, to blue, okay, right? Because we wanted to see people drinking good water as opposed to people drinking bad water. Okay. We've initially recruited about 10,000 people. Now there are about 28,000 people in the study. And they still come back year after year. So what we were doing was not only testing the wells, but following the arsenic in their urine, because arsenic is excreted in your urine. So we know what they're drinking, even if they don't tell us what they're drinking, okay? And then we were following the health effects. And we were giving them healthcare, which they didn't have in these villages, right? So that's why we retained about 98% of the people in the study over these 28 years, because they were getting free healthcare. Not just free, because we had doctors in the field doing the study, but we realized pretty quickly, well, anybody who could walk to our facility there could get free healthcare, meaning they could get a diagnosis. But then what are you going to do? Write a prescription? They're going to go to the pharmacy? There's no pharmacy. So we stocked a pharmacy and we gave them free medicine. So all this goodwill, in terms of dealing with populations, civic engagement, one of the prides of Drexel, think about not just what you want to get out of the study, think about what your subjects can get out of the study. And yes, we showed that there's an excess of cancer. I'm not going to go into detail on this. This is just to make a point about environment, bad exposure, bad health, bad productivity, right? And here's an example of the bad productivity. So we looked at what was this doing, these different health endpoints in terms of their ability of people to work and have a normal lifespan. And there's a lot of charts up there. You don't have to read them now. It turns out that the most important thing, we thought, well, cancer is going to be the most important. No, it's those lesions on the hands and feet. As I said, manual labor economy, right? And that affects you first, right? So cancer is going to kill you in 5 to 10 years, but this is going to affect you in a year or two. Get work, no good. So the GNP of the gross domestic product of Bangladesh is about 150 million, let's say. Okay, so 150 billion, I'm sorry, a year, annual. So $2 billion out of that is a significant chunk of money, right? So what do? You want to fix the problem, right? Invest something, fix the problem, and then you're going to save all this money. You have to spend money up front to fix it, but you're going to save all this money. The problem is Bangladesh doesn't have the money to fix the problem. We'll show you how we thought about that. So this was not, when we went, the second trip we went, already people had realized capitalism was great, right? Okay, if there's a problem, we'll give people what they want. We'll charge them money, we'll make money on it. So we could buy bottled water, which was arsenic free. We tested what? Okay, but the people in Bangladesh can't live that way, right? They can't afford to do that. They have to come up with another solution. We went through many, many options. The two that worked in Bangladesh were the ones in yellow. Well switching, which I'll explain in deep wells. Okay, so what is well switching? That's a younger version of me, much younger. But this makes a point. This slide makes a very big point because this is a typical village where you have 2 wells. In this case, they're only about 8 feet apart. In many cases, they're on opposite ends of the village, but very typical. And you may not be able to see the colors, but this one, I think this one is red and this one is green because we were testing the wells. And at that point, if it was safe, we painted green. If it was not safe, painted red. Tell the people to drink the green water, right? Okay. So, but my point is, you can't tell just by looking where it is. If one well is bad, the other well is going to be bad or good. You have to test every single well, millions of wells. Actually, we tested about 30,000 wells, something like that. Eventually, we went to a better marker because the paint only lasts about 9 months in Bangladesh. You have to go back and repaint all the time. We put on more permanent markers, which were obvious. Now, the problem was, in a village like this, you could say, okay, drink the clean water, not the bad water, and people would presumably do that. Presumably, if you build it, they may come, maybe not. But what about a place like this? These villages here, where it's all red. Well, what you have to do is find a different solution. So what we did is looked at the aquifers deeper in the soil, right? If you go down a couple hundred feet, you hit aquifers that don't have microbes and don't have arsenic, okay? Or anything else. We tested for everything else. There were a few other things that were interesting, but not significant. So then we started drilling deep wells, so that we ended up with this situation. And this demonstrates, first you have to decide where the deep aquifers are, and that's a very interesting study. We'll go into it. But this shows that you go deeper, you go from a mixture of wells, that are green all the way to brown. If you go deep enough, they're all green. Okay, so you go deep enough, you're going to get arsenic-free water. Okay, and then what you have to decide is where do you put them? The question becomes, how far will people walk to get clean water, right? And these are usually the women in the villages carrying these big pots of it. So turns out about 200 meters is the limit. Did a study. So wherever we had everybody in the study area eventually within 200 meters of clean water, right? Problem solved, right? Right? No, right. Why not? Because people don't do what you tell them to do. We'll get to this in a minute. So like I said, if you build it, they may come, but they may not. And if they come, they may not use it correctly. Another engineering thing to think about. You make a device, think about how people can screw it up, okay? Really, seriously, okay? People are very ingenious this way. And let me tell you, so even though we told everybody in the villages, drink the clean water, don't drink the bad water, that was not that we were not the right messenger. So another important, when you want to get a message across, have the right, not just the right message, the right messenger. Problem many times with diarrhea, for example, when they were trying to convince people to boil water, which was not so good, but and it wouldn't work with arsenic, obviously. So they have what are called clown educators. They come into the villages with a day-long show. They bring food. You have a big festival, lots of skits and shows and things, and in all the messages, somewhat subliminally, but not too much, right? The message is drink the clean water, not the bad water, okay? So we went from maybe 10% of the people listening to us to 75% of people listening, but not 100%, which raises another interesting question, and I have more on that, but for another day, okay? How do you reach the other 25%? Like the people you tell not to smoke, and they go out and smoke anyway, right? Right? We still have about 16% of the US population who smoke, including some doctors who I know. I figure that out. Okay. That's a story for another day. Okay. So, but we figured we had fixed the problem as much as possible. Could we do it for the whole country? We went to the ministry. We said, look, it would cost you about a couple $100 million to do this all over the country. Okay, that's not not a lot of money for us, right? But they said, okay, we have about $1 per person per year to spend on health, right? So they have about $150 million per year. So we're going to go for a couple of years not spending on malaria and cholera and HIV and tuberculosis. No, can't afford to. So they said, can't afford to, right? So the big problem is how is the world supposed to fix a problem like this if the country that can't fix it itself? And there's another message we're going to come to this. We didn't cause this problem for them, although you could say, well, we drilled the wells initially, so we're trying to be good. And there are lawsuits about the original wells, trust me, the lawyers are involved. But think about, now we're going to shift to climate change. Think about climate change, right? Countries like Bangladesh are suffering from climate change and they didn't cause the problem. We caused the problem, okay? So if we're just $150 million and we caused the problem, we should spend it. And the reason it's a problem is because of this, the aquifer sustainability. Well, yeah, aquifer sustainability. Because we first thought, okay, if you're going to pump from the deep wells, how long are the wells going to last, right? And it turns out if you only use it for drinking water, they'll last forever. These aquifers are very old, though. They come down from the Himalayas. They were laid down in the last ice age, right? So you're talking 20,000 years ago. Okay, but if you only use it for drinking water, you'd be fine. But actually, the biggest use of water in Bangladesh is actually for irrigation. Although it's a very wet country, there's a dry period. They usually do 3 crops a year, so they have 2 wet crops and 1 dry crop they have to irrigate. They'd have to use contaminated water for the wet crop year, okay, which is okay if they did it, right? You'd wonder how much gets in the plants that they eat, a little bit, but not much, okay? So, however, that's all other things being equal, right? I said all other things remaining constant. So what is not remaining constant besides the fact that they're pumping from the wells? The aquifers themselves. What is changing? Climate is changing it. In fact, some of the original villages we went to originally, which were near the coast, the villages are no longer there at all. And if you go a little farther inland, they can't use the wells at all because there's saline intrusion from the ocean. And what's causing all that? Climate change. And who's causing the climate change? We are. Okay? This is getting to the big message, right? Okay. So global sea level rise. And we looked at the how far it's going to. Eventually, we project, not this century, but let's say 300 years or so, about a third of the country is going to be underwater, okay? That means 50 million people have to go somewhere. Where are they going to go? India doesn't want them. We don't want them. We should, but we don't. But okay. So it's a big problem. So let's see. Where's what I think globally? Oh, here, we're getting there, okay. So, but here's my point. There are certain problems in the world, like climate change, where we are using an inordinate amount of the global resources, meaning the carbon sinks in the world, because of the way we live, we're generating so much carbon dioxide, and we are taking that ability from those countries to use those resources. I'm going to get to the ecological footprint in a minute, but that's how you measure this. So, but it comes down to the same message. We are basically colonializing other countries by the use of global resources, okay? And in doing so, we're affecting their health, and affecting their health, we're affecting their development so that they will never develop because they'll always be unhealthy because of what we're doing. Not the fact that they're dying also. So, okay, which is not a problem. So yeah, so now we got to think globally about this stuff. This is the whole globe, and we have a responsibility. So is Bangladesh and the rest of the developing world going to be stuck where they are, no matter what we do, because of the way we live? Okay. I'll eventually get to how I think we, as biomedical, well, there are two ways to think about this as a biomedical engineer, but I'll get to that. So we are causing the problem, we should help, right? That's it. So one way to think about how much of the problem is there that we are causing. Ecological footprint. How many have heard the ecological footprint? I'm sure you've heard of carbon footprint, right? She's heard of ecological. Anybody else heard of ecological? Okay, well, so carbon footprint is one part of your ecological footprint, right? It's one of those resources, or it sinks either the waste of new products or waste disposal places that we use as a society, right? And you can calculate this. So the ecological footprint is the area of land and water ecosystems required to produce the resources we use and assimilate the waste that we generate on the earth, no matter where we are, right? So just the fact that we're living in Philadelphia, we are not just drawing on Philadelphia. We're drawing on the whole country and the whole world for some of the things we eat, wear, use, etc. And the waste we generate don't just go into the Delaware River, right? They go into the ocean, and we breathe out our carbon dioxide, or burn out our carbon dioxide, and it goes everywhere. And the important thing is your footprint can't be shared. Once you use up resources and use up waste disposal sites, nobody else can use them. So if you use more than your fair share, somebody else has got to live with less, okay? And that's exactly how the world is right now. Okay, and so I won't actually go into this too deeply, but you can say, why do we do this? Okay, there are reasons why we do it. We like to live the way we live. And some of it could be genetic, and some of it is societal, as we say. So there are memes and genes involved in this. This is the way I like to summarize, right? So I love this cartoon. The end of the world scenario will be rife with unimaginable horrors, but in the meantime, the pre-end period will be filled with unprecedented opportunities for profit, right? That is the way capitalism is working globally now. I'm not anti-capitalism. We can talk about that later, but you have to do something about the bad side, the unintended side effects. So we're in essence stealing the future, selling the present, and calling it the gross domestic product. And we think that's good. We're making more money for a time. So if you look at distribution of wealth, we're doing this because we have money. And we could argue about whether the wealth of the world is distributed well or not. I would argue, looking at this, it's not, okay? But it's not so much the money, it's what we do with the money, right? And what we do with the money is buy footprint. And we're buying other people's ecological footprint with the money that we have, because we have more money than other people, so we can afford to buy their footprints, right? So what that means, and the numbers are here. I love this picture too. It's sort of, that's our Western capitalist society traversing on the world. But this is a better way. I think there's a more graphic way to look at it. If you look at our ecological footprints per capita, per person, right? You can calculate ecological footprint for each one of you, for us as a group, for the city of Philadelphia, for each state, for the United States, or for the whole world, right? You can, for any collection of people you want. But if you do it per capita and you look at how that would distort the map of the world, this is what it looks like, right? United States, Western Europe, Japan, big, big, big. What that means is these other countries are being squeezed to death. They don't have the resources because we took them. Another way to look at it, if you like, sort of numbers, and once again, these are relatively old slides, but it's still the same numbers, so you don't need to update them. So on this hand, you have the per capita ecological footprint. The United States is the biggest pig in the world, right? So almost 10 hectares per capita. What that means, and what's the global average? Look at the global average. If we're all equally distributed, everybody had the same share, it would be about 2. But every person in the United States takes 10. Okay, so that means some of these countries have to be less than 2. They're not shareable. Once we use it, it's gone. Okay. Now you could say, well, we're a pretty rich country, not only in money, but in ecological resources, right? That's true. That's what this shows. The green bars are our ecosystem reserves, ecosystem services. However, we have about 5 per person in this country, but we use 10. So we're still importing. We're importing, I would say involuntarily, from other countries, these resources, right? Now, there are developed countries like Canada have a low population, a large ecological reserve, so they actually have more ecological resources than they use. So Australia is very similar also. So those are 2 major big developed countries, but that doesn't make up for the rest of the world, the rest of the developed world. So once again, you end up with these other countries where they don't have as much as they should have if you say fair is equal. Okay? You can argue about that too, but. The other disturbing fact is this: if you look at the whole world, and this now this is even worse, because this was, what year was this? I think this was around 2010. But anyway, even 10 or 12 years ago, we were already, as a world, using more resources than we had. We're running down the earth, okay? That's not good. And what that forces is we're not only forcing other species out of existence, which maybe 1,000 species per year are dying off, going extinct. We're forcing populations of humans into the same situation, basically, okay? We're forcing them into environments where they are going to be unhealthy and non-productive, and therefore unhealthy. How does this translate into health directly? So this was from, trying to remember, this was probably about 10 years ago, but this was 2015, I think so. By 2030, and this now we're just looking at climate change. So this is your carbon footprint. And your carbon footprint is only a small, not a small portion, but it's a significant portion of your ecological footprint. In this country, about half. So any figures you see for climate, you could double, right? Okay, for your total ecological footprint. But climate is the big one. So, and that's the one that's been studied the most. So the UN says, look, we're already killing 300,000 people a year around the world because of this, okay? And we're injuring 325 million. Now think about, I initially did a very quick calculation in my head. The US population is about 300 million, right? So that means if the US were responsible for all the carbon dioxide, every 1,000 people was killing somebody every year. But we're not. It depends how, we've cut down our emissions, but the global burden that we've imposed on the world, meaning all the time we've been industrializing, is still about 25%. So that means every 4,000 people in the country are killing somebody, by these statistics, somewhere in the world every year. Which means over a lifespan of 70 years, you're talking about maybe every 60 people killing somebody. Every 6, like this room, okay? It's worse than that, though, because we are not static. We weren't static in 2050, and the 2030 projections were way off. It's much worse than that. Once again, a former colleague of mine at Columbia recently published in Nature what he thinks projects for the rest of this century the mortality cost would be, right? And look at that. Every 3.5 average Americans in their lifespan, in their lifetime, in this rest of this century, are going to kill somebody in the world by the way they live because of their ecological greediness. How many people in this room? 35. That means we're going to kill 10 people. Well, I'm going to die first. So, but you guys, if you continue living the way you're living, and maybe some of you are doing better, some of you are doing worse, but if you continue living American lifestyle, you will kill 10 people. Now, you're biomedical engineers. What do you do in the daytime in your job? What do you try to do? Save people's lives? I'm looking at you because you're smiling. What do you want to do? What do you want to do with your career? Anybody, biomedical engineering. You want to just make money? You want to save lives? You want to save lives. So you're going to spend your working lifetime saving lives, and then you're going to go home at night and kill people. That's pretty crudely, but I want you to think about that. I give this talk to physicians. I give this talk to public health people, anybody in the health field. You want to save lives. You will save lives. At the same time, if you don't change, you will kill people. How does that make you feel? Will it make you change? Do you see a different way of doing things? Change must come from within. It must come from each one of us and group and society as a group. There's a whole other lecture on how we will do this. But the point is, you are health professionals. You have a higher responsibility than the ordinary citizen because you've told me, you've come here, you want an education. We're going to give it to you. We're going to teach you how to save lives. Fine. This is another way you can save lives. You don't even need an education for this. You can just do it. Okay. Okay. So this is part of your responsibility. That's why it ties back to biomedical engineering in one way. I'm going to tell another way in a minute. Everybody get that, right? You're willing to sacrifice that car to save a life? Think about what you're willing to sacrifice for the rest of your life to save, what did I say? 10 lives, whatever. Okay. Okay. Now, I work with a lot of economists, and they say, well, no, we want the rest of the world to live like we do. I already showed you that's not possible. If they did, we would need 5 more planet Earths or 4 more planet Earths. And okay, but in the neighborhood I've lived in, we don't have many other good planets. Good planets are hard to find. People talk about going to other planets, going to Mars, let's terraform Mars, meaning make it look like Earth. Yeah, fine, but that's not going to solve the problem. So we have to solve it here. We have to solve it now in your lifetime. You have to solve it in your lifetime. I've been guilty for decades before I realized this, okay, but I changed my life. You can change your life. You got to reduce your footprint. You got to do everything you can. Okay. And the inconvenient truth really is that there are many ways we can do this, at least with climate change. Some of the other things are maybe even tougher. But in many cases, we do have the technology. What we don't have is the economic desire or the political will. And you see that in this country all the time, right? And so, so one of the message here, you want to change the world, vote right. I'm not going to tell you what's right, but think about this when you vote. Okay. And change, sometimes when I first started giving this lecture, people said, oh, we got to go back and live in caves. And, no, you don't actually, because you can make these sacrifices and still, I think, be happy. Okay, I'm happy. I'm a happy guy. And I don't want to say I made sacrifices, I made changes, right? So once again, there's a whole lot of literature on this. If you look at these curves, these are interesting. This is about subjective, objective well-being, right? So one way to look at objective well-being is lifespan, right? The more money you need money. I'm not arguing you don't need money. You need money. But at some point, how much money do you really need to be happy? Well, or healthy, right? So it turns out that you don't need a lot of money per capita to reach this plateau, right? You see it flattens out, right? In fact, if you look at the data more closely, in a country like the United States, we are spending more and more money on food that's killing us. Okay, so we are taking resources from the rest of the world and growing our obesity to the point where we're killing ourselves younger and starving other people to death because they don't have enough food. That's a very bad trade-off, right? So we're taking so much that we're dying from obesity, and we're taking from people who are starving to death. Okay, so you can live happy, you can live healthy on less, and you can live happy on less. There's a lot of studies on happiness. I think I have a slide. What makes people happy? Let's see. Oh, here it is. Okay, we'll get to that. Let's see. I did that. What did I miss? Wait a minute. Okay, so the point of this slide is objectively and subjectively, we can use our money more wisely. We can be happier and healthier, and not ruin the world. And so the politically ecologically necessary is politically infeasible, but the politically feasible is ecologically irrelevant. So, yeah, pursuit of happiness. So one way to think about it, how do we measure progress, right? So the way we measure progress now, driven mostly by the economics, is increase in growth of gross national product, right? Well, is that once again, it's not the money, it's what you do with the money, right? It's what you get from the money, right? So how many people have been to Bhutan? How many people know where Bhutan is? Okay, good. I've been to Bhutan. And Bhutan is very interesting for a lot of reasons. So it's near Bangladesh, it's north of Bangladesh, up in the Himalayas, borders on China. It's a Buddhist kingdom. They have a king. They're slowly democratizing. Are you from Bangladesh? No. I mean, from Bhutan. No. Okay. So, but 50 years ago now, the former king, his son is now king, said, we are going to develop, we want the Western advantages, but we don't want the disadvantages. So he said, we're not going to maximize gross national product. We're not going to maximize money. What we're going to maximize is gross national happiness. So he devised this equation. You can't see it, but there's an equation here. Gross national happiness index. That's what we're going to work on. The first thing is money. You need money. You can't not have money. But then there's environmental quality, education, health. All the things we think. All the things we think we really do that. So, so that's an interesting idea. It kind of got some traction in the mid 2010s when the French president convened a panel. And there are a lot of economists now thinking about this in a different way. It's not just the money, it's what you do with the money. So we're making a little bit of progress on this. But if you think about it, right? If you were filthy rich but totally unhappy, what good would that be, right? So, but if you were very happy and not rich at all, which would you rather be? Very rich and unhappy, or poor and happy, right? Interesting, or somewhere between. Okay, anyway, it's a different way to think about this. And there are some books that's not a very well-written book, but it's a nice summary of all this literature on economics, happiness, and money. But the problem is, we still think that we have to grow, right? So we think that growth and consumption, right? The United States is a consuming economy. 75% of the GNP is derived from our consumption, which is weird. But anyway, but that's not what prosperity is. That's not what progress looks like. I don't think. It's certainly not what progress looks like. Because if we keep going, we're going to run the earth out. So rethink. Spend some time thinking about these things. Go to Bhutan. People are happy there. Beautiful country. Okay, we're getting toward some more interesting stuff. But this, this part I usually end with this. I originally gave a talk at Halloween, so I put the Halloween one in there with that large carbon footprint. We are scary because we have a large carbon footprint. We are even scary because we have a large ecological footprint. And how many people remember COVID? It's an old comic strip. No, and I see This goes back to my youth, so it's a long time ago. But one of his most famous panels was this one. We have met the enemy and it is us. So if you think about the world going to hell, it's going to, that's bad news, okay? But it's not an act of God. This is not irrevocable, right? This is something we actually control. If we change, if we want to be one with everything, if we can change, we can fix this problem, right? Because we caused the problem, so we can fix the problem. We have unlimited time to fix the problem. At some point, we may run into a chip that is irredeemable, right? That can't be replaced. But if we don't, we may be selected. We certainly select out some populations. Eventually, we may select all of us out, right? So species extinction could occur to us, and we would do it to ourselves, right? The smart species, right? Homo sapiens, the wise man. Well, that's a misnomer because I don't think we're very wise because we're doing this. So maybe we're Homo stupidus, but we have a chance, right? Like I said, some people just throw up their hands and say nothing can be done. Yeah, we can be done because we are doing it. So just stop doing it. Do something else. Okay, getting back to the original. So you better bet if you're a health professional, you better make sure you're comfortable with what your moral duty is and your ecological impact is, right? Because otherwise you are killing people. Okay. So what about biomedical engineering, other than the fact that you're health professionals? So, and the reason I bring this up is maybe it's a far-fetched example, but it probably relates to where all biomedical engineering is going if you think about it more deeply. Okay, I'm just going to use this as an example, and then we can get back to that. But we have, as biomedical, so when I started in this field, I felt I had a lot of great ideas, but couldn't really do them because we weren't there yet. Now, as I come into the field again, I look at what the potential that we can do and say, wow, we can do lots of really amazing things, but do we want to do all of them? What are the good things we should do and the things maybe we don't want to do, right? But this is going to be your generation. You're going to have such power to change what even being human means, okay? But you have to give it some really deep thought. It's back to ethics again. So, and this is the way I looked at this. So as a physician, if I look at the patients I meant on practicing more, you would see patients that basically have the diseases of affluenza, right? Because they're a rich country, they spend things on things that they shouldn't spend it on, basically, and they're making themselves sick. So, but it's their environment that provides this opportunity. So we have basically so think about our genome, right? Our genome basically evolved and has been relatively static, not perfectly, but pretty static for the last 10,000 years, right? So what that means is our genome evolved in an environment that's totally different than the one in which we live, right? We were running around the savannah, chasing our breakfast, right? Doing a lot of exercise, right? Eating very little salt, very little sugar, very little fat, right? And that's how we evolved. So our bodies are tuned to being in a deprivation environment, basically. A high exercise, low calorie environment. So what do we do now? Well, we have access to, we do less exercise and we eat a lot of calories. So it's no surprise that we get diseases that are related to that. If you think about cardiovascular disease, cancer, the two big killers, definitely related, but everything else that goes along with it, hypertension, diabetes, obesity, all those things are because we have a mismatch between what our biology wants to do and what society provides us to do. And we make a bad choice. We do what society provides us, right? Okay. So if you look at it that way, there's a similar mismatch when we think about our moral responsibility, okay? So I used to think this way just about physical things, but then, so if you think about how we evolve once again, so let's take violence. So we're a very violent species, but we're also a very cooperative species. So we have this sort of dual nature. So why are we so violent? Well, one way to look at it, very simplistically, is if you were roaming the savannah looking for your breakfast and you saw another human you didn't know, what's the best first action to take, right? Well, the possibility is that they'll kill you and eat you, right? If you don't kill them first. So we grew up in these little kin groups, like small family groups. We knew everybody, we trusted everybody in that group. But anybody foreign to that, anybody that looked a little different, talked a little different, walked a little different, whatever, we would be suspicious of, rightly, because if they killed us first, we're out of the gene pool. So to stay in the gene pool, you had to have this violent suspicion, right? You had to. Otherwise, we wouldn't be here today. So that's probably one of the reasons we're still pretty violent, okay? On the other hand, it's clear that a cooperative society is one that has more reproductive success. The reasons humans have been able to populate the world is because we can work together in groups. It's just that we're still used to working in small groups and not thinking of larger groups, right? So we have this we have this, take care of the in-group, we'll do everything for them, but, beware of the other. In fact, let's get rid of the other as fast as possible, right? We get biased that way and we live that way, but you can understand, I think, that maybe genetically we are predisposed to this, okay? And that's how we got to where we are. But we're also thinking, we evolved a good brain. So if you can think about this, you could think about changing this, right? Even though our biology is telling, just like you can change your diet and change the chronic disease thing, you can change the way you approach moral problems like global problems like climate change, right? Okay. Now, maybe we need a little boost. So it turns out we do a lot of neuroengineering here, right? BIOMED, right? How many people doing neuroengineering? Anybody? Yeah, okay. So we can do interesting things with bioengineering now, right? But I'm going to focus on, I wonder if I still have the trolley problem. No, I don't. Okay. That could be an example I'll tell you later, but so it turns out that people have started to look at this. There are ways to change the way you approach a moral issue. And they could be chemical, meaning drugs. They could be mechanical, meaning FNIR, or let's say transcortical direct brain stimulation, right? Those of you who haven't had these classes yet here. There are various ways to monitor the brain, and there are various ways to change the brain, right? So you monitor it with near-infrared spectroscopy, right? What's interesting about these devices is they're portable, wearable, digital. So I could be walking around and you could be seeing how my brain is working, right? On the screen, right? That's good, right? And we present people, and when you wear these devices and you present people with a moral problem, you can see how their brain is working on that problem. So maybe it's time to give you the example of the real trolley problem. So the real trolley problem, remember you have the runaway trolley, right? And there's one person tied to the tracks. On the other, instead of your car, there are 5 people tied to the tracks. Okay. So if you do nothing in this case, the 5 people will get run over. If you throw the switch, you'll save the 5, but you'll sacrifice the other person. This is the original trolley problem. You see how that's an interesting problem? How many people would throw the switch? How many people would throw the switch? 1. So you would sacrifice 1 to save 5. Everybody else, come on, you gotta choose. I'm forcing you to choose. How many people would throw the switch? Almost. How many people would not throw the switch? Almost nobody. Okay. It's interesting because if you survey populations around the world on this question, regardless of gender, race, ethnicity, religion, politics, you get about 80 to 90% people will throw the switch, but some won't. Okay. So there are some intriguing studies that suggest that if you use FNIR, you can actually predict what you can do. Because what you end up with is 2 parts of your brain fighting each other, right? And if you could say the one that lights up the most, this seems to be possibly true. The one that lights up the most is where you're going to pick, right? Interesting, right? So I could have put these devices on you, asked the question and said, don't tell me, I'll tell you what you're going to do, right? Now, that opens the possibility because of transcortical direct brain stimulation using low electrical or magnetic fields, right? That I could change your mind. Now, we know you can use these to change your mind about other things. And it seems likely that you could change your mind on issues like this. So once I saw what you're doing, I'm not picking on you, but let's say you decide you're not going to throw the switch. And I think that's a bad idea. I could just give you a little, you wouldn't even know what was happening. You wouldn't know it. And all of a sudden you'd say, oh, no, I changed my mind. Okay. So I could change your morals just by throwing a switch. So, and there are other studies, like I said, there are drugs. The drug studies are not as clean as that because, but there are drugs. So you can have oxytocin aerosolized in this room. Everybody know what that's the maternal hormone, right? And I could do it and you wouldn't know it, right? You'd be breathing it in. You breathe it in, it goes through your nasal mucosa to your brain. It makes everybody feel happier and more collegial and loving of everybody in the room. And you wouldn't even know what's happening. So that proves I can change your brain with chemicals or direct stimulation, right? And is this a good idea or not? I mean, if I were doing it and you didn't know, I would say, well, that's probably not cricket, but okay. But what's even more interesting to me, because one of the things I'm interested in is how it's a long story, but let's say I'm interested in how you change genes to cure those chronic diseases, right? So I worked in cancer, right? We all know we're trying to do that, right? You got a broken gene, let's fix the broken gene, you won't get cancer. Or you'll cure your cancer. But think about this now. Suppose I could identify the genetic predisposition for you not throwing the switch. Once again, I'm picking on you, but right? So, because it turns out that there are about 10% of the population, any population, but let's say this population, that have a polymorphism in their serotonin receptor, right? And it turns out that that receptor, it probably predisposes you one way or another on issues like this, right? So if I wanted to make you different for the rest of your life, I could use gene therapy and change that receptor to the whichever polymorphism I want. And from then on, you'd be more inclined to make decisions one way or another. And if I delivered it to your ovaries or testes, I could make your children the same way forever, right? So I could make future generations more moral, whatever that means, right? By changing their receptor. There's a transcortical direct brain stimulation. You can see it. It does shift preference and moral judgments, just like I said. You know, I could shift you from what would be called the utilitarian. So the people who vote for saving the 5-to-1, that's a utilitarian argument. That's a mathematical calculation. That's why one part of your brain is processing that. The people who don't want to do that have are the sort of the 10 Commandments people, right? Thou shalt not kill no matter what. If I throw a switch, I'm killing somebody. If I don't do anything, yeah, people are going to do, but I didn't do anything, right? So I didn't contribute to it, right? That's another part of your brain processing. That's how you can distinguish these things. But you can also change it, just like I can change it, right? Now, if I change it for you, you have to be wearing the device. You know I'm doing something, although I wouldn't have to tell you when I'm doing it. Okay. But look at the variation in the here. This is the oxytocin receptor, right? So it's clear that people with this polymorphism make different decisions than people who have the normal gene. Okay, like I said, I could change you. I could change your children. Why not? And if the problem is we don't think about the world as everyone, you know, one with everything. If we don't think of the world that way, that we are killing people, so we're never going to know who we're killing, right? They're somewhere around the world. That's fine. They're out of sight, out of mind. We don't care. That's the way we approach it now. But if you're aware you're doing it and you need help, maybe I could give you some help, right? I could give you a little jolt. Okay. So, and people have actually, you can see 2017, should we edit the genome to make people more ethically responsible for climate change? So it's a real question. And the other question is, can we afford not to? If we really face species extinction, can we afford not to? But once again, this is just an encapsulation of what I'm really interested in. We can use biomedical engineering to treat problems you already have. Good, everybody thinks that's good, right? I think, okay. We can probably use biomedical engineering to prevent disease in people. So before they get to the stage where it's actually clinical, if we can identify what's wrong with them, let's say a broken gene, we can fix it before they get cancer, let's say, okay? But what about, so you go from this prevent disease, treat disease, what about making you better than you are now? Enhancing you as a human, whether it's morality, whether it's living longer, whatever you want to do. It's the same continuum. That's where you're headed. You can have the ability to say, just because it's normal doesn't mean it's normal. The example I like to give to the medical students is, think about cholesterol. We measure cholesterol. So how did they decide what was normal? They took a room full of people, they did a curve, they said, here's the norm, the highest point. That's normal. Well, it turns out that's statistically normal, but it's not physiologically normal. Because at the old level, and we keep moving it down. Why? Because we know that the statistics don't match the physiology. Once again, because of the mismatch of our genomes, right? So the truth is, what's normal now is not meant to be normal necessarily forever. So just because we say we're going to return you to your baseline state of health, is that good enough? Should we stop there? Enhancement, right? And if you think enhancing people is a bad idea, I'm enhanced all the time because I can't see any of you now, okay? So all of us use enhancements and we accept that. My question is, do you want to accept it when it's a permanent change? Well, I mean, people get laser surgery, LASIK now. Okay, that's a permanent change. But that's fixing something that's broken. There are athletes who get LASIKs to get 20/10 vision because they can make better baskets. That's an enhancement, right? People are getting enhanced already. You may have had caffeine this morning before your test because you wanted to enhance your cognitive ability. That's an enhancement. But we're going to we're going to have the potential to do some significant enhancement, right? Meaning, you want to live to 150? I don't think we can, personally, this is just my take on it. I don't think we can, make lifespan infinite. But I think 150 might be possible. Would you want to do that? Would you want to be smarter? Would you want to be prettier, whatever that means? Would you want to be more moral, right? This is what I think should be a no-brainer. I think we should all be more moral. The rest of this stuff you can argue about. We should do it. So I don't know if any of you have read either of these books. Yuval Harari has written some very interesting books. He's got a series now. This was his number 2 on Homo Deus, right? So we are becoming, so that means man God, but God is man, man is God, right? We are coming to the place where in the past, we didn't have the potential to do these things, but we do now. Seriously, and you will have to face this. Do you want to do this? Should we do it? Who should we do it to, right? And that's, if you're interested in enhancing it. So my point is, you are now not just biomedical engineers, you can be evolutionary engineers. You can change how we evolve intentionally, right? Rather than just making it random, you know, all right, he looks pretty good, I'll mate with him, okay, maybe we'll have better children, right? Okay, no, that's pretty random, right? You may or may not, okay? But, you know, now we could decide, we really can decide. Would that make us something more, you know, Homo sapiens 2.0? Is that good or bad, right? Well, so one person, if you have, so if you're into neuroengineering, read 1,000 Great. There are a lot, I have a lot of good books for people in neuroengineering to read about. But this is one, he says, you know, why should we, you know, leave it to chance? Well, first of all, we have to decide where we want to go, and then we agree that we want to go there and see if we can do it. But the truth is, why should we leave it to chance? If it means species of extinction, if the option is going extinct or becoming a better species, you decide. And since you're all humans yet, I will take any questions. Thank you.